Hello and welcome. In our previous video, we introduced the concept of trig functions. In this video, as the title suggests, we're going to be using a lot of those trig functions to solving a variety of problems here. I think you're going to find that these represent some very, very powerful tools that you can start using almost immediately. But let's first take some time for ourselves to isolate ourselves not only from the rest of the external world and all the distractions that come our way, but also the distractions that come inside here. Let's clear our minds so that we can be completely in the moment. Let's lose our minds and come to our senses here. Take some time for that. Welcome back. Here's an example of something that I did in a previous life, so to speak. This was in the 1990s. I worked at the weather station at Colorado State University. It's close to the Lurie Student Center, just a few hundred yards northwest of it, actually. And this included some nighttime shifts in which you have to basically spend the night at the weather station, this single room about the size of a large walk-in closet, so to speak, and you would set an alarm to go off every 2 hours, and you'd wake up from the alarm rather bleary-eyed and walk outside under the stars and make a weather observation. Now, among the things that we had to do if it were cloudy outside is to turn on this light that would help us to identify and measure the height of the lowest cloud base. And so what it was is basically this really bright light. I'm going to remove myself here from the picture so you can see this. It was a really bright light that we would turn on, and it would make a mark at it would light up the bottom portion of a nearby cloud, and we would walk over to a location that was nearby, a location whose distance from the light we knew. I think it was like 200 feet or so. And then I would measure with something called a ceilometer what the angle of declination was between the horizon line and how high up that light up portion of the cloud is. So that would give an angle measure that would help us in determining the height of the cloud here. By the way, it wasn't actually a bat signal that would show up at the base of the cloud, but I had fun putting that in. This is the kind of problem that we're going to be spending some time today learning how to solve, and we'll come back to this problem at the end and actually solve it. Here's a review of some of the stuff that we went through last time here. We introduced the concept of trig functions using an example triangle here. We worked specifically with the angle 25 degrees, and we identified 3 different sides here that we labeled the opposite side, the adjacent side, and the hypotenuse. We colored them yellow, blue, and green respectively. Excuse me. And to find the sine of 25 degrees, that's the opposite over the hypotenuse. And so we got a ratio there for 25 degrees that was extracted from these 2 sides here, 3.4 divided by 8.235. And so we could get that by finding the ratio of those two sides. We could also get that by putting in 25 degrees into our calculator and finding out what the sine value is for 25 degrees. Either way, we'd get that ratio, that same ratio that's showing up there, 0.41287. We could also take a look at the cosine of 25 degrees. In this case, we're looking at the adjacent over the hypotenuse. So that's 7.5 over 8.235. That gives us a ratio of 0.91075. That's what we get from dividing those two numbers. It's also the number that we would get if we were to type in 25 degrees into our calculator and hit the cosine button. And lastly, tangent. Tangent of 25 degrees. Now we're looking at opposite over adjacent. That's the yellow over the blue, or 3.4 divided by 7.5. Kitty, you're getting in the way here. Yes, I know you want lovey-doveys, but not now. So when we divide those two things out, we get a ratio of 0.45333. We're still going to make noise, aren't we, Kitty? Okay, whatever. So we get a ratio of 0.45333. That's the ratio that we get from those sides. It's also the ratio that we would get from the angle measure if we were to put 25 degrees into the calculator and find the tangent of that angle. No, Kitty, you can't come up here right now. So once again, we summarized all these things in the form of a single word, SOHCAHTOA. Don't throw up a hairball right here. Not now. Yeah. Okay. You okay? Yuck. All right, so the way that we, and Kitty, and as before, we summarized all three of these trig functions into a single word, a mnemonic device, which was SOHCAHTOA, which is simply sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, so let's take a look at this example here. In this example, we're given a triangle. It looks like we're given two of the three sides here. A is equal to 7 and C is equal to 21. And we want to find the measure of an angle. So since we're finding the measurement of an angle, we're going to be using one of the inverse trig functions, since we're going to find the size of an angle. But which inverse trig function are we going to be using? Well, let's see, we're given two of the three sides, so we'll only be able to use one of the three here, one of the three inverse trig functions. What are the two sides that we're given here? Well, we're given the hypotenuse, so it's going to be either sine or cosine, since sine uses hypotenuse and cosine uses hypotenuse. But what's the other side here that's above my head? That's 7. That's the opposite side, so we're given opposite and hypotenuse. Okay, so it's sine we're going to be using here. Sine is equal to opposite over hypotenuse, so the equation that we can write here is the sine of A is equal to 7 over 21. 7 over 21 is just 0.3333. And if we plug 0.3333 into the inverse sine function, we get an angle measure of 19.5 degrees. You see how powerful this is? We can calculate the size of that angle based upon the lengths of sides. Pretty powerful stuff. Here's another example here. In this case, we're wanting to find the measure of angle B. Well, that's a little different. Okay, so we're looking at the measure of angle B. We're given two out of the three sides here. I suppose we could find the measure of the third side here. You know how we could do that, right? Using the Pythagorean theorem here. But the easiest approach is to use the two that we're given. We know that we're going to use either sine or cosine because one of the sides they give us is the hypotenuse. That's C equals 45. And what is the other side that they're giving us? The one that's just to the left here. In relation to the angle B, is that the opposite side or the adjacent side? As it turns out, that's the opposite side. This is the side that's opposite angle B. So it's opposite and hypotenuse. Those are the two sides that we have here. So are we going to be using sine, cosine, or tangent? We're going to be using, again, sine. The sine of angle B is equal to opposite over hypotenuse, 35 over 45, which if we do that division, we get 0.7778. I think I've rounded that last digit there up to 8. All right, so that's the ratio that we're going to be putting into your calculator and doing the inverse sine to find the measure of angle B. That should say B of 51.1 degrees. That should be, you should be B. So the angle measure there is 51.1 degrees, and we've gotten that from the measure of 2 out of the 3 sides. Remember, this only works for right triangles. Keep that in mind. But once you have a right triangle, you've got a very, very powerful tool here. So you'll see here a pattern that pops up over and over again when you're doing problems of this type here involving trigonometry here, and that's where we find where we're working with the ratios of sides from the triangle as well as from the calculator, and you'll see more about that in a second here. So we're wanting to find the measure of the side of B, and so which trig function are we going to be using here? Well, one of these sides is hypotenuse, so it's going to be sine or cosine, and the side B just to the left of me here, again, that's the opposite side from angle B up top there. So again, it's opposite over hypotenuse, so we're going to be using sine once again. So the sine of B from the triangle is B over 85. So opposite over hypotenuse, that's all we're saying here. The sine of angle 67 is opposite over hypotenuse. Well, let's find out what the sine of 67 degrees is. Well, that's where the calculator comes in, doesn't it? We can find out what the sine of 67 degrees is from the calculator. And as it turns out, it's 0.9205. So what we do, we've got sine 67 degrees and sine 67 degrees. Let's just set those two things equal to each other. So B over 85 is the same thing as 0.9205. Same thing in both of those columns there. From the triangle and from the calculator, we have two values that are both equal to the sine of 67 degrees. So we have this equation here in the upper left, which is B over 85 is equal to 0.9205. And we can solve for B there and get 78.24. So using this kind of technique, find the length of side A here. You're given angle A and side C. Take some time to calculate what the length of that side is. Welcome back. Well, this problem was very similar to the one that we did in the previous slide there. You were given an angle 53.5 degrees. You found that hopefully found that the best trig function to use in this situation was sine, because you were given opposite and hypotenuse to work with here. One we wanted to know and the other one we already did know. And so you set up an equation there. Sine of 53.5 degrees is equal to a over 15. And from your calculator, you can find out what the value of the sine of 53.5 degrees is. It was 0.8039. So setting those two things equal to each other, or plugging in 0.8039 into sine of 53.5 degrees, gives us a over 15 is equal to 0.8039. And you can solve that equation for a to get 12.06 meters. So do this one here as well. Find the length of side T. You're given one other side there of 25 and an angle measure of 32. Take some time for that. Welcome back. Well, this problem was very similar to the previous problem, that you're using sine as your relevant trig function here. The sine of 32 degrees is equal to opposite over hypotenuse, which is 25 over t. From that point, it was a little more challenging in that you had to use a few more acrobatics in order to solve for t. You get the original function there, sine of 32 degrees is equal to 25 over t, so you have to multiply both sides by t to get it out of that denominator first. So now we've got t times the sine of 32 degrees on the left-hand side, which is equal to 25 on the right-hand side. Now we can get t by itself by dividing both sides by the sine of 32 degrees. So we have t is equal to 25 divided by the sine of 32 degrees. And here's where you can make use of your calculator. So we've figured out the trig function element from the triangle here. We've gotten our ratio from the triangle here. We've created our equation. Here's the part where we use the calculator to find out what the sine of 32 degrees is. And once we find out what that is, we divide that into 25 degrees and we get 47.18. So that's the length of side T. Here's another example. In this case, we're wanting to solve for angle A here, but in this case, I don't have the value for the opposite side, do I? The opposite side is A. It's directly above my head, and we don't have the value for that. We do have the value for the adjacent side, 1.9 feet here, and we do have the value for the hypotenuse. So which trig function should we be using? Adjacent over hypotenuse, that's cosine. So it's the cosine of A that's going to be equal to 1.9 divided by 3.6. And once we enter that into the calculator, we find out what the inverse cosine of that is, and we find out what angle A is, 58.14 degrees. So it's the same process here, except we're using cosine instead of sine. So with that in mind, do this problem here. Find the length of side B based upon that angle measure, angle A, and the hypotenuse that you're given there of 42 centimeters. Take some time for that. Welcome back. Well, you can see that in the last couple of problems I haven't been immediately finding out what the value of the trig function is. I keep the trig function, cosine or sine, whatever, still as part of the equation, and I manipulate it with other members of the equation just like it were a variable or a coefficient or whatever. So you can see another example of that there. I'm just saying b is equal to 42 times whatever the cosine of 19.5 degrees is. That's fine. And that's only then, after I'm done manipulating it, that I actually find out what the cosine of 19.5 degrees is, and then I multiply it by 42 to get 39.59 centimeters. Hopefully that's not too confusing there. Now sometimes the orientation of the right triangle can be a little misleading here. So where's the hypotenuse on this triangle? Think a moment to see exactly where that is. Remember, the hypotenuse is the side that's opposite the right angle. It's the longest of all three of the sides. And so keep that in mind as you're finding out what t is based upon the information that's given to you for this right triangle. Take some time for that. Welcome back. Well, the important part of this was recognizing that the hypotenuse was in an unusual place for this triangle here. It was on the bottom. It was t, actually. So when we are trying to find the measure of t, we're actually trying to find the measure of the hypotenuse here based upon angle r, which is 55 degrees, and the other side, which is an adjacent side. So in this case, we're using the cosine of 55 degrees, which is adjacent over hypotenuse, 15 over t. So we have to solve that equation for t, again, by multiplying both sides by t so that we can get t out of the denominator, and then dividing both sides by the cosine of 55 degrees so that t can be by itself. We have t is equal to 15 meters divided by the cosine of 55 degrees, and what we get is 26.15 meters. So you can see we can use these trig functions to calculate any of the sides of the right triangle, including the longest side, or the hypotenuse. Alright, so we've been working with sine and cosine, so you can probably guess what we're going to be working with next here. We've got an angle A, and I'm giving you two sides, neither one of which is the hypotenuse. Well, there's only one trig function that doesn't involve the hypotenuse, that's TOA. Tangent is opposite over adjacent. Opposite over adjacent in this case is 14 divided by 16, so the tangent of A is equal to 14 over 16. And so in order to find out what the measure of angle A is, we find the inverse tangent of 14 over 16. So in this case, remember, you have to put in 14 divided by 16 equals into your calculator and find out what that is, and then take that that decimal and input that into your inverse tangent function on your calculator. So once you do that, you should get 41.19 degrees. I've been sort of habitually rounding off degrees to the nearest hundredth. That's just my own personal preference as I'm doing this. I'll indicate to you in tests what decimal place I want you to round things off on, both with angles and with sides, so worry not. Alright, so here's another example here. Here we're not trying to find an angle, we're trying to find the side. We're trying to find side A here. We're given an angle measure of 44.5 degrees, and we're given one side which is 6 centimeters. Now, one thing to keep in mind here is that 44.5 degrees, that's pretty close to 45 degrees. So this thing is pretty close to a 45, 45, 90 degree triangle, and so that means that the 6 centimeter side here and side A, those are almost the same length here. This is close to an isosceles right triangle here. So we should get a measure for side A that's close to 6 centimeters here. Let's see if that actually happens here. In this case, which trig function are we going to be using? You probably already know the answer, but you can tell by noticing that we've got one side which is the opposite side. We're trying to find that. We are given the length of the adjacent side, that's 6 centimeters. Opposite over adjacent, we're working with tangent. So the tangent of 44.5 degrees is equal to A divided by 6 centimeters. We can solve that for A by multiplying both sides by 6 centimeters, and so we have A is equal to 6 centimeters times whatever the tangent of 44.5 degrees is. And what we get is 5.90 centimeters there. So you can see, as predicted, it's pretty close to 6 centimeters. So with that in mind, work on this particular problem here. You are given an angle measure of 19 degrees, and you're given one other side, and you're supposed to find that third side there. Take some time for that. Welcome back. Well, as you might have guessed from our previous slides here, we are making use once again of the tangent function here. Tangent of 19 degrees is equal to 10 centimeters divided by b. In this case, we want to get b out of the denominator there, so we multiply both sides by b and then divide both sides by the tangent of 19 degrees so that b can be by itself. The result there is 29.04 centimeters for the side b. Now sometimes when you're working with right triangles and you're working with angles and sides, you might be tempted to use trigonometric functions, and they're very useful in some situations, but sometimes it's actually just best to use the Pythagorean theorem in order to find the length of one side given the other two. You can actually use trig functions in order to find that out, but it's easier just to use Pythagorean theorem. So don't lose sight of the Pythagorean theorem here. What in this case is the easiest way to find c? Well, It's actually just to use the Pythagorean theorem there. A squared plus b squared equals c squared. So 6 squared plus 9 squared equals c squared. That's 36 plus 81, or 117. So c is actually the square root of 117, which for 2 decimal places is 10.82. We didn't have to use trigonometry at all for that, just the Pythagorean theorem. And with that in mind, we can actually use the Pythagorean theorem for this problem here to find out what the length of that hypotenuse is. If we find out what the length of that hypotenuse is, then we can use any of the 3 trig functions in order to find the measure of angle B. We could use inverse sine, inverse cosine, or inverse tangent. But since we're already given the opposite side of 8 meters, and the adjacent side of 2 meters, do we really need to go and find the length of that hypotenuse in order to find out what B is? We've got opposite and adjacent already. We can just make use of inverse tangent to find out what the measure of angle B is there. So tangent of B is equal to 8 meters over 2 meters. So the inverse tangent of 8 divided by 2, it's actually just the inverse tangent of 4, isn't it, will give us the measure of angle B, which in this case is 75.96 degrees. So this is a lesson in being able to take a look at a problem and discerning what is the shortest distance between 2 points, so to speak. What is the quickest way in which I can solve this problem? There's a bunch of ways to get to the right answer, but some might take a little bit more work and time than others. All right, so here's an example here. Here's an airplane that's taking off at a takeoff angle of 30 degrees, and from that takeoff point there, they've gone an additional 875 feet across the ground. So we can ask ourselves, how can we find the altitude? Well, how would we find that? What's the easiest way in which we could find that? As it turns out, we've got 30 degrees there, and what 2 sides have we got there? Do we have the hypotenuse? No, we don't have the hypotenuse. We've got the other 2 sides. We've got opposite and adjacent. So we want to use tangent in order to find out what that altitude is. The tangent of 30 degrees is equal to x divided by 875, which means that x is equal to 875 times the tangent of 30 degrees, which is going to be 505.18 feet. You can calculate the altitude of that plane given the distance across the ground and the angle measure of takeoff. Here's another example here. So you actually run into this when you are driving on I-70 coming out of the mountains and into the valley of Denver, Colorado. This is you oftentimes find all these signs that are warning these 18-wheelers that, you know, there's going to be a strong drop-off point here for the next few miles here. So watch your brakes and make sure they don't overheat. And if they do, make sure that you go into these specifically designated areas that are designed for your safety to glide you to a safe a safe stop. And we've got some rather infamous cases in the news that have come recently in which 18-wheeler drivers have failed to do so and have resulted in some accident and actually some deaths. So the angle of declination here is something that we want to find, and it's something that for each stretch of roadway, and here the roadway is not horizontal, is it? It's going downward. So each stretch of roadway drops 30 feet for every 300 feet of road. So think to yourself, what's the appropriate trig function here to find that angle of downwards, the angle of drop-off, basically, that the road is going down. So take some time for that. Welcome back. Well, it might have been a bit of a temptation to make use of the tangent function instead of the sine function. If that were the case, then you were thinking in terms of 300 feet being along that horizontal side instead of the one that was going down. For the one that's going down, that's the hypotenuse. So we want to make use of sine of the angle theta being 30 feet over 300 feet, or simply just 0.1. So the inverse sine of 0.1 is 5.74 degrees. That's actually a pretty steep downward decline for a roadway. Here's some other examples here. Find the angle that a rafter makes with a joist of a house if the rise is 12 feet and the span is 30 feet. So this is an example of a rafter here. The rise in the center there is 12 feet and the span from one side to the other is 30 feet, which means that if we're wanting to find the length of one of those roofs, I mean, we're actually taking a look at two different triangles, aren't we? Two triangles that are really the same. And so this is a good example of a case here in which we don't have to make use of a trig function in order to get the solution that we're getting. We just want to find the length of the roof here. And so we've got the length of one side, which is 12 feet, that's the vertical side, and the horizontal side is actually half of 30 since there are two triangles there. So the horizontal side is going to be 15 feet, and so 12 squared plus 15 squared is going to be c squared to find out the length of the roof line there, the rafters. So 144 plus 225, that's 369. The square root of 369 is 19.21. So 19.21 feet for the length of that rafter there. And we could actually find out what the angle is of that by taking the inverse tangent of 12 over 15. That's the opposite over adjacent. We can find out the measure of angle theta there, and what we get is 38.66 degrees. Here's another kind of problem that you can do here. Find the angle formed by the rod in a mechanical assembly shown in the figure. So this is kind of like a rod that you would find spinning around a wheel in a locomotive or something, or the flywheel of an engine that's going around in circles here. So sometimes it's on this side of it's spinning around a wheel and going back and forth. My elbow's going back and forth, and my hand is spinning around a wheel here. And so sometimes the rod has an angle that's like this, sometimes it has an angle that's like this, but how do we figure out what the size of that angle is compared to the horizontal in either one of those directions there? Well, that angle is theta. I don't know that I've said in any of these videos here, but that symbol is actually theta. It's a Greek letter, so it's what we usually use in order to describe what an angle is. So angle theta there, and we've got the length of the radius of that flywheel there, and we've got the length of the arm from my elbow to my fist being 59 centimeters. And so we can find out the size of that angle when that angle is really at its greatest there. So take some time to solve that. Welcome back. Well, this was another instance of using inverse sine there. We're given the opposite and the hypotenuse. So we're using that ratio in order to figure out what the angle is using inverse sine, and we get an angle measure of 10.35 degrees. So here's another concept that I'll sometimes ask of you. We'll probably even ask you to do so on an exam here, and that's called solving the triangle. In other words, I've given you a triangle here in which I've given you part of the information in terms of sides and angles. I want you to find out what everything else is. So in this triangle here, we are given one side, which is 24 inches. I'd like you to find out what the other two sides are. And in addition to that, there is one angle E, that we do not know what that angle is, and so find out what that angle is. Well, this is the kind of thing where you can take this one step at a time here and ask yourself, what's the easiest thing first for me to find here? And there's a bunch of ways to approach this here, but let's actually start by finding out what the hypotenuse is here. So in this case, we've got an angle measure of 32.5 degrees. I don't know what the opposite side is, but I know what the adjacent side is. It's 24 inches. I want to find out the hypotenuse, so I want to make use of cosine here. So cosine of 32.5 degrees is equal to adjacent over hypotenuse, 24 over f. And so f is going to be equal to 24 over cosine of 32.5 degrees. I've solved that equation for f, and so the result there is that I'm going to be able to find out what f is. In addition here, I can also try to find out what the size of side D is. In this case, I'm using tangent of 32.5 degrees, and that's equal to opposite over adjacent, so D over 24. And I can use that in order to find out what the size of side D is. So that's going to be all of my sides. And then I can find out what the measure of angle E is just by remembering that all three of the triangles add up to 180. So it's going to be whatever 180 minus 90 minus 32.5 is. And so I can actually solve for all three things based upon what I've got here. F is going to be equal to 28.46 inches, D is going to be equal to 15.29 inches, and E is going to be equal to 57.5 inches. And in addition to this, there's actually some checks that we can do, just to make sure that all the information that we've got makes sense. One thing that you can do is make use of the Pythagorean theorem. We've got three measures of sides here now, two of which we calculated using trig functions, so the Pythagorean theorem should hold for all of these things, and as it turns out, it does. And so that's a solid check here. We can also check to make sure that all the angles add up to 180 degrees. That should happen, and again, it does. So when you're doing these kinds of problems, it's pretty straightforward here. You identify what's given to you, identify what's missing, and figure out a strategy to find each part here. Okay, so I can find out what this side is. I have this angle and this side, so I can use this trig function to find out what that is. I've got this side and this side. I can use the Pythagorean theorem to find this side, so on and so forth. Just come up with a plan to find each part. You don't even have to have a plan for the whole triangle all at once. Just have a plan for the next angle, the next side that you want to try and find. And that's actually part 4 there. Just focus on one part at a time. Don't get overwhelmed with the entire triangle when you're solving a triangle here. And you can do some checks on these things. You can check the sides using the Pythagorean theorem. It should, those sides should conform to that. If you plug all of those things into the Pythagorean theorem, you should get a true statement. In addition, when you plug the angles, when you add the angles up, you should get 180 degrees, or something very close to it if you've got a rounding error or something, 179.9 or 180.1, something like that. So I'm going to have you do this. Solve the triangle here. I'm giving you a triangle there. There are no angles other than the right angle. You have to find both of those angles. I'm giving you 2 of the 3 sides. Take some time for that. Welcome back. Well, you've got two angles to find, both with trig functions, choosing the trig function of your choice here to be able to find each one of those angles there. So I used cosine in order to find A, and I used sine there to find B. Both of those were equal to 1.9 over 3.6. That gave us a measure of angle A of 58.14 degrees and a measure of angle B of 31.86 degrees. Again, if you were to add those angles up and also add 90 onto that, you should get 180. In addition, we can find the size of side A by making use of the size of angle A, which we now know as 58.14 degrees. If we take the sine of that, that's equal to A divided by the hypotenuse, 3.6 feet, and the result that we get for side A is 3.06 feet. And then once again we can use the fact that the angles are supplementary as a check. We can also use the Pythagorean theorem to make sure that all the sides are giving us a reasonable answer. So that's a nice little check to make sure that you've got the right answer. All right, so let's come back to this problem here that I introduced near the beginning here, where I'm working at a weather station and we've got a nighttime light that's shining to the base of a cloud, and I'm using a ceilometer to measure an angle from my location on the ground 200 feet away from the base of that light up to a point where the light is shining onto the cloud. So what would I be using in order to find the measure of side X? Well, you can probably see here that I would use tangent. I would use tangent. The tangent of 82 degrees is equal to X divided by 200 feet. And the result that I would get when I solved that equation for X would be, as you can see above my head here, 1,400 feet. That's how we would calculate the cloud base at night using that vertical light and a ceilometer and some trigonometry. So that's the end of this particular one. Again, make sure that you've gone through your activity sheet here to list off what are the most important things to remember from this particular video that we were working on here today. In particular, those steps that I listed for solving some of these problems 2 or 3 slides ago, I think would be important for you to list near the top of your activity sheet, where I give you some notes to summarize things that are discussed here in the video. So take some time to do that as always. Well, that is the end of our last video here together for Math 107. I'm always sorry to see you guys go, but I am overjoyed at watching you succeed and move on. I hope you had as much fun with these videos as I had making them, and I wish you really the best of luck on the exam as well as in your future endeavors. Take care.